This should be easy, just a ball falling onto a table. But somehow, AI struggles to make the motion behave right. And that is what makes this interesting. Because these are not just weird AI videos, they point to something deeper. Why AI doesn't understand physics. So why does it struggle with something this simple? The model has learned the visual pattern of a bouncing ball. But that is not the same as learning the constraints that make the bounce possible. A video model is trained to generate a plausible sequence of images. One frame can look plausible, the next frame can look plausible. But a plausible looking sequence is not automatically a physically correct world. Because physics is not just what appears in each frame, it is what has to stay true between the frames. A bounce is not just a ball going down and then up again. The ball has to stay the same object, the table has to stay solid, and the motion has to follow from the moment before. If that connection breaks, the video can still look close, but the world inside it is no longer coherent. That is what I mean by understanding physics here. Not just knowing the words, not just recognizing the pattern, but keeping the world consistent as a physical world. But maybe I just picked a bad generation. Maybe another prompt would work better. And sometimes it does. So is this actually a broader problem? When researchers test video models more carefully, they separate two questions. Does the video look realistic? And does it follow the physical rule behind the scene? That is what benchmarks like physics IQ are trying to measure. A collision can look like a collision, but the contact does not stay consistent. Water can look like water, but the motion does not behave like water. A shadow can look realistic, but not stay connected to the scene. So the bouncing ball is not proof by itself. It is one simple example of a gap researchers test more broadly. But if AI struggles with physical video, does that mean AI is useless for physics? And the answer is no. AI can be very useful for physics. It can help with calculations, it can analyze data, it can find patterns, it can write simulation code. But notice what all of these have in common. In those cases, the problem is already shaped for the model. There is data, there are variables, there is code, there is a task. The world has already been translated into something the model can work with. And that does not contradict the bouncing ball. It just means the tests are different. In one case, AI works with a prepared physical description. In the other, it has to generate the world itself. But then why does it matter if it is only a generated video? For a video generator, it barely matters. The ball moves wrong, the clip looks strange, you just regenerate it. But the same failure becomes much more serious when AI has to act in the world. A robot cannot regenerate reality. If it loses where the cup is, it grabs empty space. If it gets contact wrong, it cannot push, catch, or avoid objects reliably. If it predicts the next moment wrong, its next action is based on a world that does not exist. That is the hard transition, from making a video to navigating reality. In a video, broken physics is a visual mistake. In the real world, broken physics becomes a wrong action. That is why the bouncing ball matters. It is not interesting because it is complicated. It is interesting because it is simple. Even here, the model has to keep a small world from breaking. Looking real is not enough. A world has to work. The same ball, the same table. The next moment following from the last one. And the rules that decide what cannot happen. So the question is not whether AI can say what physics is. It is whether it can generate a world that actually obeys it. And right now, that is exactly where it still breaks.